let's think about the domain of a rational function. So reminder, a rational function is something that looks like this, right? R for rational function. A rational function is something where we have a polynomial divided by another polynomial. So here is a perfect example of a rational function. We have x squared minus 4, that's a quadratic polynomial, divided by x plus 2, that's a straight line, that's a single degree polynomial. So this is a rational function. And if I think about the domain of a rational function, well, I can plug any real number that I want into the top polynomial, and I'm going to get a real number out. I can plug any number that I want into the bottom polynomial, and I'm going to get a real number out. The only problem that might happen is if I divide by 0. In other words, what's going to make this x plus 2 equal to 0? So when I'm looking for the domain of a rational function, I'm going to set my denominator equal to 0, and then figure out where that happens. So this one's not too difficult to solve for. If x is equal to minus 2, then this denominator right there is going to be 0, meaning that this rational function is not going to exist because you can't divide by 0. So the domain of this rational function, in fact, the domain of any rational function, are the zeros of your denominator. Therefore, this rational function has a domain minus infinity up to minus 2, and then minus 2 to infinity. All right, we just skip over minus 2. It exists over the entire real number line except at minus 2.